No, okay. This class, this next section is magnitude and I think of the other one. We did scientific notation last class. I'm trying to remember what it is, but I don't remember. But is there any questions on the homework or the process or anything?
No.
Okay. I opened up the grade book so you can see it now, and it is weighted. I think it's correct. I tested a couple people, but we don't have a lot of grades yet. So I will check again. I like to just figure it out by hand and make sure it matches properly. But if you ever notice anything's missing or not there, let me know and I will check into it. So double check that your grades are there. The only thing that might not be, I just put the introduce yourself, so I don't have everyone's grade in. And if you didn't do the introduce yourself, make sure that you get that done this week. If you're able to stay after class, I can do it then. Or we can set up another time. Did we have homework last night?
Yes.
Okay. So homework. I try not to give too much homework other than those attendance problems. Once in a while there'll be homework just to make sure you understand something maybe. But other than the projects, I'd rather give more of those and not have a lot of homework. So I want to see how that'll work this semester. So the homework though, if you ever need to check, let me share. Okay. Just click here, attendance, homework, and projects. And it'll give you them. So this was last week's attendance. Here's the project and then these. So if there was another homework assignment, it would be here. Any questions on that?
No.
A few people added, if you have added, after I gave out the project, let me know. I think everyone's gotten with me, but if you haven't, let me know and I'll let you know what project or what height you could do. Because a couple people dropped, so any other questions?
No.
So quiet. I don't know what it is today. It's hard to get moving. I think because I don't have any other classes today.
Lucky.
I don't know. I still got lots of work. Okay. So section 1.3 works with estimates, precision, orders of magnitude. And I think this was a good example from your book. An old storyteller tells a museum guard who's posted next to the skeletons one day, and he was in charge of the skeleton. So a young kid asks him how old the skeleton is, and he says 70 million 3 years old. Well, how does the guy know it's so precise? Because if we're putting this 3 at the end, then all of these values are precise. And so he asked the guy, and the guy said, well, I started here 3 years ago, and I was told that the skeleton was 70 million years old. So you add 3 onto that, it's 70 million and 3 years old. But that 70 million was just an estimate. We didn't know exactly. And so there's a lot of different ways of giving values. And when it's really large, we usually estimate it. And instead of being exact, 70 million and 3 years old. Sometimes we'll say it is 70 million. Sometimes they may give an estimate, 65 to 75 million years old. And that would be give or take 5 million then, because you're taking your 70, adding 5 and subtracting 5 million. So there's a lot of different ways to give very large values, and usually, or very small, and usually we don't give an exact value when it gets that large. Here's 4 examples of a way you could talk about the population of the Earth. The Earth is, and this would be at, I don't know at what point, but at one point this was exact. The population of the Earth is about 7 billion, plus or minus a billion. I don't think that's right. But your book said that one. I could see plus or minus 100 million maybe.
I think we actually just hit the 8 million mark.
Yeah. 1,000 million. Oh, that's right, billion. Okay. I don't know, the decimal messed me up on that one. I was reading it wrong. You could also say 10 to the 9th or 10 to the 10th. A lot of books use 7.2 times 10 to the 7th, scientific notation. This we'll get into significant figures in this section. This would be 2 significant figures. This one would be 1, 2, 3, 6, 9, 10 significant digits, because all of these are significant, where 7 billion is only 1 significant digit. And the definition of those is below, but let's see. Yeah, we are almost, well, we probably did hit it. If this was January 1st, 7.9 million billion, 7.9 billion. So when you're asked to do a problem and we're estimating the population of the world, I would take anything around 7 to 8 billion. Because we're going to be estimating a lot. And that would be fine. You do not need an exact value, somewhere between 7 and 8 billion. And there's a lot of different ways of expressing that value. The same thing with the population of the United States. Does anyone have an estimate for the population of the US?
2 billion?
2 billion?
It's 1.5 billion. You know, 1 billion, final answer.
Now we could estimate 1 billion could be a rounding. It's somewhere around 332 billion. Million. Now you have me saying billion.
Uh-huh.
But that could estimate to a billion. I mean, it's not halfway there, but it's close. So instead of billions, we will estimate the US in millions, 300 million to 400 million, somewhere in there. Last year it was 332, I think. So 336 now. So somewhere in the 330 millions. So anywhere in there would be a fine estimate when you're doing an estimate for the United States. You do not need an exact value. And that's a lot of what this section is showing you. When numbers get too large, putting all those values it doesn't mean much. So 336 million would be the same as saying 335,962,130. When we get that large, we don't have to be as precise or small. Any questions on that?
No.
Now, sometimes I was just thinking about it. Sometimes when you're getting small, there are areas where you still need to be precise when you're talking about medicine and you're putting small amounts into an IV. Certain things still need to be exact, but in a lot of cases, when something's very large or very small, we can estimate it. A few definitions, and I won't ask for a definition. It's just you need to understand the wording when you're doing problems, but I won't ask for definitions. A measurement claim about some physical or environmental quantity is the claim that the true value of that quantity lies in a certain range. If they're saying that there's 10 tons of plastic in a certain area, that's an estimate. It's not an exact value. Precision of a measurement claim describes the width and the range of the values within the true value of the quantity is claimed. This width can be described explicitly or expressed implicitly using scientific figures. I don't know why I said scientific, sorry, I'm stuck in science. Significant figures. That would be 10 to the 5th. So we are rounding things. So if we look at this, when we're talking about significant figures, a lot of times they're using scientific notation. Not always, but a lot of times they do. There's, I think it's just 6 rules. All non-zero numbers are significant. So 33.2, 3 significant figures. 33,000, 335,264, 127. These are all significant digits because they're all numbers. Zeros between 2 digits are significant. So if I took out this 2 and put in a 0, this still has 9 significant digits because the 0 is between 2 numbers. So it is still an exact or precise value. This was not a rounding because that 7 is there. Any questions so far? So all the digits that are not 0 are always significant. If there's a 0 between them, it is also significant. We know that that value was a 0. It wasn't an estimate. If this was an estimate, then this would be a 0 also. Leading zeros are not significant. They're nothing more than placeholders, like the 0 here or here. So if you have zeros in front of this, you wouldn't have the parentheses, I mean the commas, but if you had these zeros, then these still, it's only 9. So zeros in front of value are not significant. This would be 3 significant digits. Now, if we put a number in front of this, now they're significant because they're between 2 numbers. So that goes back to rule number 2. But if it's all leading zeros in front, you don't count those. But if they're between 2 numbers, then you would. This would be 1, 2, 3, 4, 5, 6, 7. Where this one's only 3. Any questions on that part?
No.
Trailing zeros to the right of a decimal are significant. There are 4 significant figures. But you have to be careful when it's saying that. Trailing zeros to the right of a decimal are significant. There are 4 significant figures in 92.00. That's different than 92 though. So if they're putting zeros after a decimal place, then those are rounding to 0. And so they're significant. Okay, so you have to be careful on this because we always learn you couldn't drop. Was that 92? Zeros at the end, that this is the same as 92. But it's not, it's an estimate. This is more precise because we know the next 2 values are 0. This could have been 92, could have been 92.4, and that would still round to 92. This is being more precise. It's telling you those next 2 digits are 0. So this would be 4 significant digits. This would only be 2. So depending on how precise you need your answer to be, those zeros are important. This could even be 92.49999. If we're rounding to the ones position, 92. But looking at this part, it's different. Any questions on that? So zeros after a decimal are significant. They're saying that these were zeros, not 4s or something else. Any questions on that?
No.
Now, if you have a whole number and you have zeros, if the decimal is there at the end, it's significant. Where's the example? Like 540 point, if you have the decimal point there, then you know that 0 is significant. It wasn't rounded. If it's not there, then that could have been rounded. So what they're saying is if you put a decimal place after your 0, that 0 belonged there. It wasn't rounded. For instance, 544, if we're rounding to the tens, is 540. Putting that decimal there is telling you we didn't round. This is the value that should be there. So that makes it significant, where this one doesn't, because this could have been a 0, a 1, a 2, a 3, or a 4. Any questions on that? So this one would have 3 significant digits where this one would only have 2. So this decimal is telling you this was a 0. This one you don't know. It could have even been 535. If we're rounding to the tens, that would round to 540. Any questions on that? So if the decimal point's there, you know the 0 is what it's supposed to be. It was not rounded, so it's significant. If it's not there, then it could be rounded. This would only be 2 significant digits.
Is it 2 because of the possibility that it was rounded?
Right.
Okay.
So since there was not a decimal at the end, any zeros that trail, you don't count because they could have been rounded. Even if we had 54,000. This would be 2 significant digits. So usually it's in science that you're using the significant digits. You need to be more exact with measurements. And what they would do then is put a decimal here. So we know this was not rounded. This was the actual value. This would only have 2 significant figures. This would have 5. Any questions?
No.
All right, let's look at a few. Number 1. Write an approximation in standard form. Use 1 significant figure. So we want to put it in standard. Well, it is in standard form. We'll leave it in standard and then we'll put it in scientific notation. Sometimes in your book, it puts standard form, but it wants scientific notation. But we're going to do both. If we were going to go 1 significant digit, right now we have every single one of these is a significant figure. 1, 2, 3, 6, 9, 12. Does everyone agree there's 12 significant figures right now?
Yes.
If we wanted 1 significant figure, which one would we keep? What's going to keep it closest to the number that we have?
The 4.
The 4. So if we only put 4, will we have a number close to 1,000 million, 83 billion?
No.
Yes.
I kind of need to keep the 8, huh? And so when you're trying to find a or lower it to a certain significant figure, if you think of scientific notation, it kind of helps you, because if we put this, we would go 8 point, and then if you want to keep all of it for right now, 3, 6, 9. If we were going to put this in scientific notation, we'd have to put the decimal between the 8 and the 3 so that we have a number between 1 and 10. And then we're moving our decimal place 3, 6, 9, 10. So if we wanted 1 significant figure, 8 times 10 to the 10. So if we write it in this form, it's a little easier to get your significant figures. If we wanted 3 significant figures, 8.33 times 10 to the 10. So this would be 1 significant figure, this would be 3. Now, if we needed, this is scientific notation. To put it in digit or standard. Notation. Let me make this smaller for a second. That would be putting all those zeros in. This would be 10 of them. We'd move 10 to the right. Three. Both of these are 1 significant figure. As long as I don't put a point at the end here. This one would get me 3 significant figures. Any questions on that? So this would be standard or digit notation. This is scientific notation. I don't know. It's up to you if you, I think that writing it in scientific notation and then seeing the significant digits might be easier. But always start from the front and then however many you need, and then the rest become zeros. Try another one. Any questions on that one?
No.
Okay. Number 2, according to the 2010 census, the US population in 2010 was 380 million. Find an approximate to this using 3 significant figures. So go ahead and find this value to 3 significant figures. Put it in both notations, scientific and standard. So if we start from the front, the 3, 0, and 8 are all 3 of those significant figures.
Yes.
Yes. The 0 is significant because it's between 2 numbers. So then the rest of this value, we want to get rid of. If we write this, is it better to round first? If we round, 3 significant digits would be here. We could use this, or we can keep that in 8. Proper rounding would make this a 9, so now we have 3 significant digits. But because we're estimating, I would also accept 308. but that 0 in between the number does count as a significant figure. So I would accept both. I've seen cases where they tell you to round it, and I've seen cases where they tell you just to drop these. This would be the standard or digital digit notation. And then scientific. The decimal would go between the 3 and the 0 so that you have a number between 1 and 10. And then we're moving it 3, 6, 7, 8. And it's a positive 8 because this needs to get larger. So either one would be fine. Any questions on that one?
No. Would we have to write both?
I would probably specify one or the other. If I didn't specify, it would be up to you, either one. Or sometimes I'll have both, maybe just to make sure you understand the problem or how to write it. But if I don't specify, then either one is fine. I just wanted to do both for practice. Number 3. Recent annual wheat yields in Bangladesh are stated as 1,370 pounds per acre. How many significant figures are there?
3.
So for 1,370, that 0 does not have a decimal after it. So we only count the 1, the 3, and the 7. Any questions on that?
No.
The manufacturer claims that a new hybrid automobile contains 61.07 miles per gallon. How many significant figures are implied by this?
4.
Do you believe that the manufacturer can, in fact, measure gas mileage to this level of precision? So this would be 4. Can they get that precise?
Yes.
I would think so.
I mean, they already gave us the numbers, so
Yeah, I
technically,
would
yeah.
think they could. Because if you're taking the number of miles you drive divided by the number of gallons of gas you put in, you should be able to. If I had 15 gallons of gas in my tank and I went 200 miles. I can get it precise. I think the one thing they're getting at though is the tank actually empty. Did you use all 15 gallons? Miles wise, we can definitely get that because we can look at the meter on our car. But then again, think about the meter on your car. It is not showing you all the decimals. It's rounding it. And so that could be what they're thinking about. I took this problem from the book. But I think it makes a good discussion problem because they are estimating it. When you think about your car, I think mine only shows miles. Now, I had a car when I was younger that was, the meter was a little different and it showed 1 decimal place. So it was a little more precise than the car I have now. But gallons of gas, you don't know that you necessarily used all of it. So then again, you're rounding there too, and that could be why they're saying that could be off a little. But anytime we do estimates, we could be off,
So then technically it would not be,
right? It's not as
Precise.
precise as they claim. Because of all the different roundings, you're rounding your miles, you don't know that you used every single drop of your gas that you put in there. Unless you ran out, which we don't want that to happen. One thing you could do, if it was completely full and then you went and filled it again, you'd know how many gallons you used. That would get it a little more accurate. But yeah, it's never exact, at least for cars. And I think that's what they're trying to tell you. Any questions on that?
no.
Multiplying and dividing in scientific figures, we won't do this a lot, but just in case it comes up, I wanted to go over it, because you could always just write the number and then multiply them, and it'll put your calculator will put it in scientific notation. But when you're multiplying or dividing two or more numbers, the number of significant figures in the result is the smallest number of significant figures. Oh, yeah. So if we had something that had two significant figures times something with three significant figures, you want to end with the smallest one. Multiplying or dividing, the number of significant figures in the result is the smallest number. So if we had 25 times 111. This number has two significant figures. This one has three. When we get our answer, we want to use two significant figures. So now, not all multiplication do you want to do this. Only if we were saying this is exactly 25 and this is exactly 111, and we have to multiply them together. So it's not going to come up that much. I don't think. But in case it does, when you multiply or divide, so we took 25 times 111. Now, if they wanted us to round to the proper significant figures, this one had 2. This one had 3. So this should have 2. Any questions on that? So it would be used if they tell you to use the proper significant figures. That means this needs to have 2, which would be these first 2, 2,800. Any questions on that?
So it's kind of like multiplying decimals.
I would
Like
do
you'll always keep the same decimal place pretty much.
When you multiply decimals, you count your decimal places. Like if we had 2.1 times 0.1, that would be 2 decimal places, so it's going to make it 0.21. Right? Yeah. So I wouldn't think of it as counting the decimals. I would find my significant figures for each of them, and then you take the smaller one. So multiply them and then change it to that many significant figures. Here, this one has 2 significant figures. This one only has 1. So my answer, this would stay because this has 2 significant figures. Oh no, we want 1 though. Sorry. Taking the smaller. So this has two significant figures, this has one. So this should have one, which would be the 2. And we wouldn't put a 0 here because remember, a 0 after trailing zeros after a decimal are significant. Any questions on that? Don't get too bogged down into it, because we won't use a lot of significant figures. I think they're important to understand though, because if you need to take any science classes, they will pop up a lot. So I do want you to understand them, but I'm not going to go crazy if you're not, or if you make little mistakes, I'm not gonna go crazy with them. But any questions on the basic idea of them?
No.
I don't see them a lot in mathematics, but I know my daughter does because I always talk to her about where I would find them when I would use them. She isn't a science major.
So that's where we would use them.
Yeah, more science than anything else. And because we're talking a lot about sustainability, it's probably going to pop up some. On a test, you know what, on a test, other than maybe a basic, how many significant figures does this have? I'll make it take home.
Okay.
That way, then you could ask me questions on it and make sure you understand it. But other than like those basic ones that said how many significant figures, I might put one of those on there, but like the multiplication and stuff, I won't do that. It'll be on a take home. If I feel it's needed, it will be on a take home. So what I usually do, I don't know if we talked about this for this class, for exams, I will make part of it take home and part of it in person. That way, if there's things I want you to look up on the computer and that are a little more thought process that I think might take you more time and maybe would be a good thing to talk about with other people, I'll put that on a take home. And then we'll have an in-person one that's more of the shorter problems and problems that at most would need a calculator because everyone's computer runs differently. And there's some problems I really like, but I think that they're a little harder for a 50-minute test. So I put that on the take home and then you can ask me questions, you can work with other students, and that way you have more time on those problems. So the exams will be in 2 parts. The in-person will be on the Friday of the week. The other one will be given the Sunday before and it's due the Sunday of that week. Any questions on that? We don't have one. I don't know when it's coming up now. I guess we could look that up. If you ever want to look at what we're covering for the day or the week or when tests are, if you go under, I think it's important information. Yeah, right here, weekly schedule and exam dates. All the dates are there for the exams. It's an Excel file. If you're having trouble opening it, let me know and I'll save it under something else. Okay, so it won't open for me. That's weird. Has anyone else? I opened it earlier last week. Okay, there we go. Your exam is the week of February 13th. So it's the 5th week. We have a few weeks. But on the 12th, I will put up the take-home portion, and it'll be due on the 19th. And then the in-class would be the 17th. Any questions on that? So it will be broken into 2 parts. They're pretty close, like 50-50, weight-wise. And that should be here. I don't know. I'm gonna have to check why that's not opening. Okay. This is a problem or an example doing the same thing but dividing. Also this symbol, and I think we've talked about this already. Whoops. These little squiggly lines, that just, when you're rounding, you should put that. So if you're doing a problem and you're showing all your work and then all of a sudden at the end you round, you should show those symbols like they did here. They had 316.2 divided by 9.12. And they got this value. Now they're still rounding here, but that's as far as the calculator is going to take it. Notice that this number, the top number, has how many significant figures?
4.
And the bottom has
3.
3. Now they're giving 2 significant figures. But according to our rule, we should use significant figures that are the smallest of the 2 values you're dividing. So sometimes it depends on what they want it rounded to or what makes sense for the problem. But if we were going to use this rule, we would have went to here. 34.7. Now, because they're not using proper significant figures, that's why they're saying then we should add this part that we went to significant figures. You don't have to do that. For when you're doing your work, I like to see this value and then round to here, round to 35. It's up to you. Unless it specifies round. Usually I'll say round to the whole number, round to the 10th, round to the 100th. I'm not. If I said 2 significant figures, you would not need to state that. If you're rounding on your own, show me the original answer and then show me what you rounded, and that's fine. You don't have to put two significant figures. Any questions on that?
No.
Oh, it's time. Okay, we will stop there.
Can you actually scroll back up to the first rules for the trailing zeros? I was just writing them down.
Oh, is that this one?
Yes, thank you.
Okay, yep. Now, also, these are on as you learn. If you go under outlines for class, they're all there. Any questions?
No.
Did you get that?
What?
Oh, did you get to write it all? Is I guess what I meant.
Oh yeah, I'm finishing them now.
Okay. If you go under as you learn on the left, it's I think it says, whoops, sorry, I didn't mean to do that. Outlines for class. And then this whole paper that I was just showing you is there. Section 1.1, 1.2, and 3. I didn't finish outlining all of 1.4. It'll be up there tonight. But any questions? Where's the